Hello and welcome to our class. And this class is explaining about software quality and how quality control is ensured in software systems. So I hope we are going to learn. By the end of this class, we would like to understand what it means with quality assurance and also quality control, and what are some of the tools and standards which are employed so that we can ensure software quality. So welcome and let us move together. So whenever we are talking about software quality, it normally comes from the basic understanding of software quality assurance. And when we are talking about software quality assurance, we normally refer to software quality assurance as, that is SQA, is normally referred to as a means and practice of monitoring the software engineering processes and methods used in a project to ensure proper quality or quality of the software. So basically that is what we refer to as quality assurance, and it normally comes from software quality. And like we had defined it previously, is that software quality is going to vary from one point to another, or from one user to another. With some users, they normally talk about software as fitness for purpose, that is quality being fitness for purpose. Others is what they can be able to pay for. Others, they will talk about now all its usability and such areas. But there are specific quality metrics or attributes which we normally base upon. Like normally, you would normally those quality metrics or quality attributes will always revolve around 8 areas or subcharacteristics. That is functionality. You will always hear of, sorry, that properly. Yes, you will always hear of reliability. You will also hear of operability. You can always hear of performance efficiency. You can always hear of security. You can always hear of compatibility, maintainability, and of course, transferability, which sometimes is also called um, portability, meaning that the software can operate in different platforms. So those are the attributes we normally look at when we are talking about quality, and that is what we are trying to ensure when we are defining software quality assurance. So basically, that is what it means. And in this class, we want to understand what are these quality concepts. So when we are looking at quality concepts, one is the quality of conformance. And here we are looking at the degree to which the design specifications are going to be followed. Because after you have captured requirements for the software to be developed, then those requirements are going to be transformed into system specifications, and those specifications are the ones which we are going to follow. so that we get the desired software. So when we talk about quality of conformance, we are looking at how have you followed those design specifications in getting the final software product. Then we also talk of quality control. And by quality control is the series of inspections, reviews, and tests that are going to be used to ensure that you have conformed to the product specifications. Then there is also quality assurance, and quality assurance is the process which will include auditing and reporting procedures that are used to provide management with the data needed to make proactive decisions. So those are very key concepts which you need to understand. That is quality conformance, quality control, and quality assurance. Then we move on to quality costs. Normally, there are costs which are going to be involved when you are developing a software, and it is important to know about them if you want to ensure quality. Because, like we had said previously, is that there are three items or there are three pillars which you should always maintain in an equilateral triangle. One of them is quality, the other one is time, and the last one, when we are talking about the most important, just let me just put them here, and I say there are three quality pillars, sorry, pillars that we normally look at. One of them we say is time. The software needs to be developed within the specified time. The other one is the quality itself. It has to meet the specified standards, and then the other one is costs. These three need to be always maintained. If the cost increases, then there might be a problem, because the more cost there is, then it means the software is not going to fit. So when we are talking about quality costs, is because of these three pillars that we have to always maintain when developing the software. And some of the costs we are going to look at is like prevention cost. And here, cost is going to be incurred in terms of planning. It is also going to be incurred in form of technical reviews and also the test equipment that are going to be used, as well as training. There is also appraisal cost, and this is the cost which is used in the process or in the process inspection, and also equipment calibration and maintenance. Then there is failure cost, the cost which is incurred if you are going to repeat some work that is reworking, or if you are going to repair the software maybe after testing, or if the software has failed and you have to rework it, then you are going to incur some costs which had not been factored for. And then there is also external failure costs, which are going to include things like complaint resolution. Imagine you had developed the software until it has gone to the user, maybe as a beta version or the commercial version, and then they encounter a problem with the software and they make a complaint, and it could be legal complaint. Then there's going to be complaint resolution cost. Maybe you need to pay them. Product return, if the product is returned to you, you have to work on it and you are going to incur some cost. If you need to replace that product, that is the software product, then that is also some cost which is involved. Helpline support and the warranty work. If you have given your product some warranty, maybe during 1 year of the operation of this software, if it has issues, you can bring it back at our own cost. Then that is a cost that is going to be included. So those are costs you need to understand about. Then we also have total quality management. And when we are talking about total quality management, this is a very important aspect of quality, which is important. And total quality management is going to be looking at the software as a whole, or it is going to look at all the issues that are involved in coming up with the software, or the aspects of software quality development, from uh, looking at the primary elements, looking at the development process, and then after you have looked at the development process, the maintenance process, until you get to understanding the total quality. So When we are looking at total quality management, we are looking at a structured approach, which is going to be used to look at the overall project management. The focus is going to be on the process to improve on the process of developing the software. So what are the mechanics you can put in place so that you improve on the software quality? That is what we are talking about, total quality management. And sometimes we use some of these concepts which have been developed and they have been put in place. Like when you talk of Kaizen, it is a concept in total quality management whereby you develop a process that is visible, that is repeatable, and that is measurable. The process has to be visible or has to be properly understood by the users, and then it can be repeated and then it can be measured. Then there is also Atamari in Shitsu, which is examining the intangibles. There are aspects of software development that are not tangible. Like when you are talking about looking at the cost of software or you are charging about the software, how do you do it? It is by lines of code. The software itself is not tangible, the lines of code are not tangible, or the product that you are going to come out with is not tangible. So these intangibles, which are going to affect the process and work to optimize the impact on the process, then they are measured using that concept. So that is also very important. We also have kanse, and if you look at these terms, they are mostly Japanese because, like we said, the concept of quality assurance started from Japan in the 1940s. That is why they borrowed most of the names from Japanese. And in cancer, the main concept is examining the way the product is used by the customer with the eye of improving both the product and the development process. So you are not just looking at the final product, you also need to look at the development process because it may be taking a lot of time or it may be involving a lot of cost and you want to also improve it. Then there is also Mario Kuteki in Shitsu. And this is where you observe the product use in the marketplace to uncover new product applications as well as identify new products to develop. So imagine you are looking at maybe M-Pesa, and that is a product you have in the market. And then you realize that people can use M-Pesa not only for sending money, but they can also pay using M-Pesa. So you include that as a new product, Lipa and M-Pesa. You can also find that people are saving money in M-Pesa. So you create a wallet whereby somebody can save money and so on and so on. So when you are doing that, you are employing Miriokuteki in Shitsu. Then, how do we ensure quality assurance? We have said that quality assurance is all about conformance to software requirements, and that is the foundation of how software quality is going to be ensured. These specified standards are used to define the development criteria and are also used to guide the manner in which the software is going to be engineered. So, software is going to conform to these requirements such as ease of use, maintainability, reliability, as well as the explicit requirements. When we look at those, look at them in terms of what are the functional requirements and what are the non-functional requirements. We are saying that in quality assurance, you have to ensure that all of those requirements have been met. So, in the software quality assurance group, what are the activities involved? First of all, you are going to prepare a plan for the project. Then you participate in the development of the project software process description. And then you review the software engineering activities to verify that they have complied with the software process. Then after that, you're going to audit the designated software work products. And then after you have audited, by auditing is just counter checking. There is a difference between counter checking or reviewing. When you are reviewing, you are just looking at what you had assigned. But when you are auditing to check if that has been conformed with. Then when you are ensuring that, then you are going to look at any deviations because with review and auditing, you can check where is the gap. And once you see the gap, then you can always document and record any evidence of non-compliance. Remember, when you are doing quality assurance, you are doing it for a product that is already finished or for a product whose plan has been developed, whose framework is already developed, and you want to see that it fits to the requirements that you have put in place. Then after that, you will come to software reviews. And when you are doing reviews, you are doing them to check if there are any defects or errors before it is passed to another engineering activity. So software engineers and other guys whom we call maybe software testers and walkthrough managers, they are going to conduct formal technical reviews, FTR, and these ones are just there to see if the code is up to standard, to see if the specifications are up to standard, and using those formal technical reviews like walkthroughs and inspections, then you are going to check where there is a gap, and then you can improve on the software quality. So the review roles are going to have guys like the presenter or the person who is designing the whole document, and then there is a coordinator, the person who is going to invite different guys who are required in the quality review process, and then there's going to be a recorder or a rapporteur, the person who is going to record the events of the meeting and is going to build a paper trail. Like we said, documenting is very important. So whatever is happening, they are documenting so that you can have a reference point of what took place or what was found to be the issue. Then there is going to be the reviewers themselves. These are the people who are going to maintain the system. They are the people who bear the standards so that they can tell whether that system is up to standard. There are also people who are going to represent users to see if there is the user perspective. Like we said, when you are doing testing or when you are reviewing the software, you can do it from a developer's perspective, and you also need to do it from a user perspective, because at the end of the day, acceptance testing is very important. So when we are talking of an FTR or a formal technical review, we refer to a process that is going to involve 3 to 5 people, including the reviewers, and they need to prepare in advance, that is 2 or more hours before, and the duration of the meeting should not be more than 2 hours. And then the focus of the review is on a discrete work product, and then the review leader will always organize the review meeting and at the producer's requests. So whenever the software developer has requested that we need a review, then the review leader also will always organize for that meeting, and it happens. Then reviewers are going to ask questions that are going to enable the producer or the software developer to discover his or her own error. The product is under review, not the producer. That is what you need to note. And then the producer or the developer of the work walks the reviewers through the product, how it works, and then a recorder will be writing down any significant issues during the review, and then the reviewers are going to decide either to accept or reject the work product and whether to require additional reviews of the product or not. Then, why do we do those peer reviews? Because normally it is peers who are reviewing one another. This is a developer who has come up with a software, and because it is not possible for the developer to see his or her own mistakes, they are going to invite other developers who are familiar with maybe that programming language, that programming standard, and they are going to review. So that is why we call it peer reviews. So why we do peer reviews is to improve the quality, and then 80% of errors can be caught if the work is done properly, the review work. And then you can catch both coding errors and design errors, and also enforce the spirit of any organization standards or any programming standard or coding standards, whatever it is. And then there will be also a chance for training and insurance. Insurance is in the aspect that you can be assured that the system is up to standard. Then, how do you do it in a formal way? You're going to have formal review presentations whereby you resemble like conference. If you have attended a conference, there are going to be a panelist, there is going to be a team of panelists, and that team of panelists are going to be reviewing what the presenter is doing, who should be the developer. Then there is also informal presentations, which are less detailed but equally correct. And then they tend to be formal, so keeping time is very important. And then later, you can also have informal discussions whereby you can be giving feedback on areas that were not touched on during the formal meetings. Then, how do we ensure that formality is adhered? Analysis should be complete. Remember, now we are looking at those stages of development. So analysis is where you were doing the in-depth study of the system that is required. So that should be complete. The design of the system should be complete. And then you should have done the first compilation. You should have done the first test run. And then after all of those, you need to do another test run to ensure that the product is okay. And then anytime you complete an activity, then you should produce a working product. So that is how you're going to ensure formality. Then review guidelines, they should be short. They should also be scheduled like 2 in a row, and the review should not include the fragments of the product. It should be the whole product, and then using standards so that you avoid disagreements. Like if we are saying we are following maybe object-oriented programming standard, then that is what should be followed so that there are no disagreements, because different developers are going to have different standards, but then they should agree on one standard that is followed, and then that is it. And then the coordinator of that meeting should run the meeting and maintain order. So, how do you approach this formal software quality assurance? You approach it by ensuring that there is proof of correctness. There is also statistical quality assurance. Like when we are talking about proof of correctness, if you are talking about performance, how did the system perform in terms of maybe feedback to the user? It took less time. You can record maybe statistically 2 seconds, 2 microseconds, something like that. So that is a measure which can be used to either say it is of quality or not of quality. And then that is where we are talking about statistical and then clean room process that combines item 1 and 2. That is proving correctness and statistical quality assurance. Then the statistical quality assurance is going to be the information about software defects, and it is collected and categorized. Like each defect is traced back to its cause, and then you use the Pareto principle whereby it says that 80% of defects can be traced to 20% of causes. And so you need to isolate the few defects which are vital so that you can work on the solutions. Then, how do you measure software reliability? First of all, software reliability is defined as the probability of failure free operation of a computer program in a specified environment for a specified time period. And this can be measured directly and estimated using historical and development data. So the other quality factors can be measured before the product is released. But we are saying software reliability is only going to be measured when the software is put into use in a specified environment and for a specified period of time. That is where now you can say that this software is reliable or not reliable. Software reliability problems can usually be traced back to errors in design or implementation. Some errors may be hidden until the software has been exposed to a certain environment, and then they will be discovered. That is why we normally say that they can only be discovered during the operation of the system. Then reliability metrics. Which metrics or which functional units can we use to ensure that the software is reliable? These are the units of measure for software reliability, and it can be measured by the number of operational failures and relating these to demands made on the system at the time of failure. Maybe you are testing the stress levels. Imagine we are looking at the system that is normally used to release results to students. During the exam time, that system is not used so much. But after results have been released, let's say it is KCSE or KCPE, everybody is sending requests to the server, and the server might be overwhelmed. It may be stressed. And at that time is when now you can be able to measure during that stress level, whereby it is receiving maybe millions of requests per second. Is it able to withstand that pressure, or is it going to shut down, or is it going to be overwhelmed? So that is where you can measure reliability, where you are looking at, did it fail, or was it able to give the results? So a long-term measurement program is required, because a short period of time you may not be able to say that it is of quality, but after a long period of time you can be able to check on that. And this is where we talk about metrics like probability of failure on demand. Like at that time, how did it, was it able to fail, and or was it able to deliver? Then rate of fault occurrence, whereby if it was able to fail, how many times did it fail, or how many times did it shut down? So that is the kind of measurement you can always use. And you see here, you are able to give some statistical number, meaning that for one in every 1,000 requests, the service is going to pay per unit time, or two failures for each 100 operations time units of operation. So with these metrics, you can be able now to say the software is reliable or not. Also, mean time to failure, the average time between observed failures and availability. How is the system available even during the stress level periods? And then time in terms of units, we can talk about raw execution time, whereby it is working non-stop. Also, you can talk of calendar time. If the system has regular usage patterns, you can now talk of the system has been running maybe for 1 year, even if it was shut down for maintenance, but it has been running for 1 year without any issues, only maintenance. Or it has been running maybe for 365 days non-stop, or it has given this number of transactions for this period of time. So that is how you can be able to test it. And then there is also software safety. And when we are looking at software safety, we are talking about an activity that focuses on identifying potential hazards that may cause a software to fail. And when we are looking at the hazards that may be available, we are looking at the developers specifying the design features that are going to eliminate or are going to control the impact of potential hazards. And software reliability involves determining the likelihood of a failure occurring and the consequences of failure. So, how do we do that, or how do we validate that? We can do that by reliability validation, whereby we are measuring the system reliability to meet the specification, or is the system reliable enough to satisfy users. Then we can also do safety validation, whereby we are asking, does the system operate so that accidents do not occur, or are accident consequences minimized? Then security validation is the system secure against external attack? Then, what are the validation techniques? We can have statistic techniques such as design reviews and program inspections, mathematical arguments. We can also have dynamic techniques such as statistical testing, scenario-based testing, and runtime checking. Then there is process validation, whereby software engineering processes which are minimizing the chances of introduction of system defects. And here we discuss the static validation techniques, which could be including things like structured arguments and mathematical proofs. Then we also have safety validation techniques, whereby we are demonstrating safety by testing where the system is under stress, or testing all possible situations that the system could be exposed to see if it can withstand them. Then safety reviews, we could be asking questions like, is the intended system function correct? Is the structure maintainable and understandable? You can verify the algorithm and data structure design against the specification. Then we can check the code consistency with algorithm and data structure design. We can also review the adequacy of system testing. Then there is also hazard-driven analysis, whereby we are looking at the effective safety assurance, which is relying on identifying some of the possible hazards. And safety can be assured by hazard avoidance, accident avoidance, and protection systems. So safety reviews should demonstrate that one or more of these techniques have been applied to avoid those hazards. And then system safety case, this is the normal practice for formal safety case to be required. Like you run the system for some time, you put it under different stress circumstances, and you see how it is going to behave. And arguments can be based on formal proof, design rationale, safety proofs, and process factors. All of those need to be documented. And then poker, poker yoke devices, these are mechanisms that are lead to the prevention of potential quality problems before it occurs, or to the rapid detection of a quality problem if one is introduced. So they could be simple, cheap, but part of the process engineering process, which are located near the process tasks where the mistakes are likely to occur. So it's like you are introducing a problem to see if the system is able to detect, or to see if the system can be able to withstand that problem or error, and then you correct it before you release the system to the market or to the user. That is what it is meant by poker yoke design, the devices. So the plan should start with the management section, whereby you are going to describe the structure and organization. Then you document, there should be documentation, and then you also follow standards, practices, and conventions. Then after that, you're going to perform reviews and audits, and then you get to the test section, where you are making references to the test plan, and then following the processes that have been put in place to record the test, how it has behaved. And then at the end of the day, you will need to report any problem and any corrective action that has been proposed, so that now the developer can go back and look at the system in terms of correcting that problem. And then tools and methods that have been used, they need to be documented or included in that report. So that is basically the introductory part of ensuring quality of systems. So thank you for your time, and good day.